Hello everyone, welcome to this Crash Course series session 8. Today we are going to talk about more about organic. Today is very special session because we are going to cover entire important named reactions in organic chemistry. From the basics to advanced level. So let's get started. Students, make a note of it. Any which way, I'll be uploading these checklist on named reactions in the description, and I'll be giving you this session notes because there are a lot of reactions here now. So I'll be uploading those lecture notes also. So please be attentive, please be careful while doing these reactions. So without any further delay, let's get started. First, we need to understand some reactions. There are three types of organic reactions, isn't it? One is majorly classified three type is addition, substitution, and finally elimination. So whatever the reactions you are seeing, whatever the reactant and the product mechanisms you are seeing, those will come under these three categories: addition, substitution, and elimination. Hope you guys know what are these three reaction types. Addition, just adding A plus B gives C, that kind of addition. Substitution means instead of Br, OH will replace. Instead of Cl, Br will get replaced. So replacement reactions you can say. And finally elimination, small molecule will get eliminated. H2O will get eliminated, or Cl2 gas, SO2 gas, some small molecules will get eliminated. So that is elimination reaction. So in these three types, I would like to classify into more, depend on their nature of reactant. That is, whether that can be of nucleophile, whether that can be of electrophile. So what is electrophile? So electrophiles are the electron-loving species, which wants more and more electron. Phile means deficiency, you can consider. So phile, which meaning deficiency. So which is having electrophile, that means electron is deficient there. So it needs more electron. So these are electron loving species. And the second category, that is nucleophilic. Don't consider nucleus loving species, it's just opposite to electrophile. So electron hating species. It is or you can say electron rich. So the nucleophiles are electron rich and the electrophiles are electron deficient species. Okay, so in these names you can see the mechanisms like electrophilic addition, nucleophilic addition, electrophilic substitution reaction, nucleophilic substitution reactions. Okay, mostly you will be encountering these type of reaction mechanism in entire 11th and 12th. So let's see what are the general rules we can consider to predict the product. The first thing is electrophilic substitution reaction. The point, first let's see electrophilic substitution reaction. So electrophile you can consider which will be having the plus charges, or sometimes it can be neutral also. I'll tell you the examples. Positively charged electrophile, for example H plus, H3O plus, or Br plus, or ammonium ion NH4 plus, or you can take NO2 plus. So these are some electrophiles possessing plus positive charge. There are some electrophiles which are not having charges. Neutral electrophiles are also exist. For example, these Lewis acids, BF3, AlCl3, SO3, FeCl3. Okay, so these categories you can consider as a neutral electrophiles. For example, nucleophile. Cl minus, Br minus, I minus, F minus, whatever comes under minus charge, which are electron rich, Cn minus. Okay, so they are nucleophiles, and neutral nucleophiles include H2O, ammonia, ROR, ether, or you can take ROH, alcohol. So these are some electron rich, which are having lone pairs or which are having minus charge in it. Okay, so in case of electrophilic substitution reaction, you can expect the questions from aromatic substitutions. Because in aromatic substitutions, we have many reactions. For example, aromatic nitration, substitution, in that case, sulfonation, or you can take Friedel-Crafts acylation or alkylation, halogenation, which includes ClBr, everything, halogenation. So these are some important reactions when we are considering aromatic electrophilic substitution. What need to do, ma'am, to predict the product? Okay, so one rule you have to follow, that is, if electron withdrawing group is there, if nothing is there in the benzene ring, just a benzene, they are giving the electrophile as a HNO3 or H2SO4 for nitration and sulfonation and all, just put the electrophile over there, any places. Out of 6, any place you can put. But if the substitution is already present there in the ring, for example, like this. For example, like this. If a substitution is already present over there, what I have to do? Which position I have to put the electrophile? Right? So, ma'am, you're saying substitution. You can remove the NO2 and put the electrophile. No, you can't do like that. Because that should be placed where the electrophile will attack where electron rich. Right? So, we have to see which positions are electron rich in the presence of substitutions. Okay? Substituents. Here I am having NH2, NO2. Does it matter? Yes. There are electron withdrawing groups and electron donating groups. It affects the benzene ring. Okay? It creates the electron deficient position or electron rich position across the benzene ring. Okay? So while predicting the product, please make a note of it. While predicting the product, if electron withdrawing group is there, then you have to go for ortho and para positions. Please make a note of it. If there is electron withdrawing group in the ring, then you have to place the electrophiles in meta position. Meta position, which means the third position from the substituent. From NH2, this is meta. This is ortho, this is para, this is meta, and this is ortho. Okay, these two positions are ortho, these two positions are meta, and the opposite one, that is para. Electron withdrawing group is there means you have to put it in meta position. Electron donating group is there means you have to put it in ortho para positions. Depending on the crowding, you can decide which should be the major product in case of ortho and para. Okay, so electron withdrawing, electron donating. The case 3 is both are present. Both are present. Electron withdrawing is also present, electron donating is also present. In that case, you have to go with the strength. So decide according to the strength. If I'm taking nitro group and I'm taking NH2 group, so according to this table, you can see I'm attaching this. You can see which is more electron withdrawing, which is more electron donating. Depend on the priority, depend on these preferences or strongness, you can decide. So go with this strength. So if nitro is more priority order, like if that is more deactivating, if that is more electron withdrawing when compared to other donating group or another electron withdrawing group, then you have to go with this from the nitro position, meta position you have to take. Okay, so for example, here I'm having nitro and let's say I'm having CN in another position. So comparing CN and nitro, nitro is most reactivating, nitro is more electron withdrawing than the cyanide. So the incoming electrophile should go to meta position to nitro. So which means it can go here or here. So the answer is will come like this. Okay. So you have to consider the strength order as well. So for that you have to remember these orders. Then we are moving into nucleophilic substitution reaction. Here you can see the common nucleophilic substitutions are SN1 and SN2. So SN1 and SN2, which is entirely different, but there are some common features which is nucleophile. So simple. First of all, the questions can be asked from either mechanism or intermediates or rate law or apart from that examples. So we'll see some examples also. Before that, let's see what is SN1 and what is SN2. SN1, as a name indicates, it is a nucleophilic substitution unimolecular. Unimolecular means in the rate law or rate determining step, I can see only one molecule is fixing that. Okay. In a substitution, we do have a reactant and a nucleophile, right? But the reactant only decides the rate of the reaction, not the nucleophile. So in that case, that is unimolecular. So it is following the two-step mechanism. The first step is formation of carbocation and the second step is nucleophilic attack. The first step is slow step, which is the rate determining step also. In case of SN2, it is single step mechanism, happens simultaneously, bond breaking and bond making happen simultaneously, and that is bimolecular reaction. The rate law, you can see that reactant is affecting the rate law. In case of SN2, nucleophile and as well as reactant molecule is also affected. That is second order, this is first order. And the rate determining step is carbocation formation. Here that is a complete reaction. And the substrate preferences, tertiary, secondary, primary. Tertiary carbocation is most stable carbocation. So carbocation formation is the most important step over here. That's why it is following this order. It should be stable. The intermediate should be stable enough to proceed with the reaction, right? So SN1 follows tertiary, secondary, primary, and SN2 follows, mostly it will not give the reaction for tertiary, only primary and secondary. Comparing primary and secondary, primary gives better than the secondary. Talking about the stereochemistry, racemization happens, some retention possible due to the ion pairs. You can take this part alone, retention in configuration. Solvent preferences: polar protic solvents preferred SN1, and polar aprotic solvents which are not having hydrogens in it, they will prefer SN2 reactions because that interfere the reaction mechanism. And nucleophilic strength, that is not important in case of determining the rate of the reaction. Even the weak nucleophiles will work for SN1 reaction, but in case of SN2, the strong nucleophile is highly recommended. High temperature favors the reaction, and SN2, it's independent on the temperature. Leaving group, which is important, good leaving groups required to be I minus, the strong, so that it will, the bigger ones is present over there means that can be eliminated easily. So the carbocation formation will be much more easier. And SN2 also the same order preference for leaving group. Some of the examples you can see which prefers carbocation formation of tertiary ion, and then here the primary ions follows through SN2. As I told you, nucleophile doesn't affect the rate, and activation energy is generally higher due to the carbocation formation. In case of SN2, that is lower because it is a single step reaction, concerted mechanism. Then let's go into nucleophilic substitution reactions and Main reactions. This is about SN1 and SN2 and electrophilic substitution and nucleophilic substitution reactions. Let's see the named reactions, which is covering the entire organic chemistry of 11th and 12th. Aldehydes, ketones and carboxylic acid, alcohol, phenol and ether, amines, hydrocarbons and UOC. So entire named reactions in one single video. Let's get started. Filkinstein reaction, which comes in halo part. This is very important. The question directly can be asked from this. How will you convert Cl to I? Just NaI, sodium iodide, you can use to get it converted. So this follows SN2 displacement. And Schwarz reaction, you can see, I think 2018 question paper, they have asked the conversion of chlorides to fluoride in the presence of AgF. What is that reaction? Schwarz reaction. So that these two are super important in haloalkanes and haloarenes part. Then in case of gentle stuff, you have to know about the Seystaff rule. Here, the more substituted alkane is more preferred, the major product. Hoffman's rule says that the less substituted alkenes are the major products in case of A2 elimination. So it's depend on the reactant side. Then Markovnikov's rule, it explains the hydrogen or the negative adenine part will go to more substituted carbon. The negative adenine will go to more substituted carbon. More substituted carbon. More substituted means what? Which is having less number of hydrogens or less number of hydrogens. You can also remember if I am substituting HBr means H plus will be forming Br minus, right? So H plus, that will go to more number of hydrogens which is less substituted. Br minus will go to more substituted carbon which is less number of hydrogens. So just to remember one thing, you know the famous dialogue, rich getting richer, right? So H plus will go to where the hydrogens are more. Okay, here you can see H plus just went to CH3 part, CH2 part, so it became CH3. So rich getting richer, just remember that in case of Markovnikov. And anti-Markovnikov, just the opposite. It follows the free radical addition. And there are some reactions you can see in the halo chapter itself which follows anti-Markovnikov rule. Coupling reactions, Wood's reaction, which is for higher alkanes formation. Alkanes formation from halo, it is forming higher number of alkanes. You can't form methane out of this reaction. The initial product starts from the carbon 2. Then Wood's splitting reaction, which is a combination of aromatic and aliphatic. It forms aromatic alkanes. Okay, aromatic with alkyl group attached. Fitting reaction, it is for only aromatic. Wood's is for aliphatic. Fitting is for aromatic. Wood's fitting means aromatic and aliphatic. Then alcohol and ethers part, Williamson synthesis, super important. RH, it is forming ROR, the presence of sodium ethoxide or sodium oxide alkoxide ion. It follows SN2 substitution. Whatever the reactions you are studying, study with the mechanism part. Or at least what mechanism it is following. So in your examination, if you are failed to do what the product will be forming also, if you know the mechanism clearly, you can predict the product very easily. Then Lucas test, the very famous test which used to distinguish primary, secondary and tertiary alcohols. Lucas test, it goes according to SN1 or SN2. It's entirely depend on which alcohol is present over there. It is also giving RCl. Okay, so Lucas test is super important. Please note down. Then aldol condensation. Aldol condensation. So both the aldehydes are getting together to form a product. It involves the elimination of water and nucleophilic addition happens over there. So this is aldol, and after elimination it is forming a alkene. Okay, this is aldol. Cross aldol condensation means both the aldehydes are different, but this product will be same, mechanism will be same, just the aldehydes are different. That's it. Cannizzaro reaction, hydrogen shift happens over there. The formation of products are alcohol. Cannizzaro reaction, here you can see, you can observe one thing, it is undergoing the disproportionation reaction. Okay, so I am taking aldehyde. So aldehyde, upon reduction, it will give alcohol, right? Upon oxidation, it will give carboxylic acid. What is disproportionation reaction? Same reactant will give reduction product also, oxidizing product also. The same thing happens over here. So please be careful with Cannizzaro reaction. And cross to Cannizzaro, as I said, the aldehydes will be different. Mechanism would be same, the product formation would be same, but the aldehydes are different. Clemmensen reduction, It is a famous reduction for CO group change to CH2. Carbonyl is just getting shifted to CH2. It is taking place via organometallic intermediate. And Wolff-Kishner. Wolff-Kishner and Clemmensen, you can see the difference, that is HCl, it is acid catalyzed reaction, Clemmensen, and the base catalyzed reaction is Wolff-Kishner reaction. But the product and the reactants are same. I mean, they are taking carbonyl group only. But in case of Clemmensen, zinc amalgam. But in case of Wolff-Kishner, it is following hydrazine. Hydrazine with base, it is forming the reduced product. MPV, Melvin Pond of Verley, it is undergoing isopropoxide, aluminium isopropoxide, that will give you alcohol. So you can see alcohol means that you start with an aldehyde or ketone. Here you can say just to ketone, that is giving us secondary alcohol. So one thing I want to make you sure that primary alcohol will give you, upon oxidation, will give you aldehyde. On further oxidation, it will give you carboxylic acid. Secondary alcohol, that will give you ketone, and upon oxidation, it will give, again that will give you carboxylic acid with less number of carbons. Carboxylic acid with less number of carbons. Because two different carboxylic acid it will be forming. So this is super important. Please note it down somewhere. Then HBZ. HBZ, here you can have to see it is taking place in the presence of phosphorus and I2. Red phosphorus I2, it is just giving you CHX, the halo substituted carboxylic acid. It is getting substituted in alpha position. Alpha halogenation is taking place in case of HBZ reaction. Gold's electrolysis, which comes in hydrocarbon chapter, you can see that is formation of decarboxylation happens, CO2 will get eliminated, and then coupling. Coupling means what? Join together. So alkanes will be forming. Then aromatic substitution. We already talked about aromatic substitution, how it happens. Nitration, sulfonation, halogenation, Friedel-Crafts alkylation, Friedel-Crafts acylation. So everything happens through aromatic substitution. You have to check with the substituent what is present over there. If substituent already which is there in the aromatic ring, that is, if that is an electron donating group, you have to go with ortho and para positions. If that is an electron withdrawing group like nitro, cyanide, like that, so you have to go with meta directing. Meta position, the substituent will come and attack. Okay. So that follows the Friedel-Crafts alkylation. The one more important question here you can consider, that is why we are using AlCl3. Okay. So here AlCl3 is working as a Lewis acid. What is Lewis acid? It is having a vacant orbital to accommodate the lone pair. Correct? So AlCl3, which is having the vacant orbital, so upon the Cl, or you can take any Cl2 also, ROCl is there, means this RO part will get attached over there and Cl should form. Cl will attack AlCl3 to form AlCl4 plus. Okay, this is acting as a electrophile, and Cl minus will attack AlCl3 to form For the formation of electrophile, this AlCl3 is used. AlCl3 is a Lewis acid, which is having a vacant orbital in it. Then the important reaction, that is Diamond-Diamond reaction, which happens in the presence of chloroform and base. The question you can expect over here is intermediate. What kind of intermediate it is forming? So please be careful with the mechanism of this reaction. It is forming CHCl2. Okay, so then that will attack, that mechanism will get, it will be forming, the carbene addition is happening over there. Okay, then Golgi schemate, that is giving you carboxylic acid again, it is following electrophilic substitution reaction. Diazonium reactions. In case of diazonium, so many named reactions are there in diazonium salt itself. The most important reactions I just listed, Sand-Meyer reaction, you can see the single electron transfer happening, copper Cl2, or copper should be in +1 oxidation state. It gives you haloarenes, like benzene with substituted halogens. So please be careful with what is the reactant over here. Sand-Meyer means you can consider, you can think about Meyer, which is bigger. So the molecule itself is bigger. That's what I tell my students to remember in that way, because most of the students doing mistake in this part. Sand-Meyer and Gattermann. Gattermann, the splitting Cu with HCl. In case of Sand-Meyer, CuX, CuCl, Cu2Cl2. That kind of reactant will be reacting. And with the elimination of N2 part, that we all know. And Hofmann-Bromamide reaction, super important. What is forming mechanism is also important. Our amines is forming. Amide to amide, amide to amine is forming over here with the elimination of CO2. KBr will be forming, or NABR, depends on the base you are taking. It is a kind of rearrangement reactions, so please be careful. And Gabriel Thallamide, one of the most important reaction, it is forming primary amine. It follows SN2 mechanism. SN2 obviously primary supports it, right? So Thallamide will get attached, and then in the last step it will get separated. Primary amines will be forming. Then let's talk about the rearrangements. Carbylamine reaction. You can see alkyl isocyanate. Isocyanate will be forming over here NC, and this is also for primary amine. The question can be asked from this part also. What are the reacting mixtures present in carbylamine reaction, or what are the end product? Super important reaction in amines chapter. Amines is reacting with chloroform with KOH, that is giving alkyl isocyanate. Okay, NC, not Cl. Phenol-phenolone reaction is not much important in case of JEE main perspective, but JEE advanced it can be asked. It is forming a carbonyl compound from alcohol. Beckmann rearrangement, these rearrangements you can omit for JEE main perspective, but Hofmann rearrangement is super important. Then Hinsberg test. Amines is reacting with sulfonyl chloride. It's an Hinsberg reagent to give different products, because it is test to differentiate primary, secondary and tertiary amines. Iodoform reaction, it is also important. Who gives iodoform positive? That is a major question. So which molecule will give you iodoform positive? Which are the carbonyl compounds that is having a CH3 in alpha position? CH3 must be there in alpha position. Alpha position you know, right? The next to the functional group. So for example, here I am taking acetone. This will give positive to haloform test or iodoform test, or acetaldehyde, that will give positive. So apart from this, any other carbonyl group will give positive to the iodoform test? Yes. You can take any long chain carbonyl group, but it should have a CH3 group in the alpha position. You can take the that is having 60 carbons also, but here I am having CH3, so that will give positive to iodoform test. So please be careful with that, and some other test to differentiate aldehydes and ketones, Tollens test, Felling's test. You should be very careful with that. Please revise those things as well. And polymers, condensation polymer, note down some examples: Buna-S, Buna-N, nylon 6,6. So please make a note of it. These rearrangement reactions. Claisen rearrangement is important. It goes for alkyl phenyl ether to orthoallyl phenol. Coming back to addition reactions. Bridge reduction. So bridge reductions happens in the presence of the reagent is important. Sodium with ammonia. Okay, so it is giving you 1,4 dihydro aromatic ring, benzene. And Diels-Alder reaction, diene should be there, dienophile. For example, diene means, here you can take two double bonded system. Dienophile means, phile means I have told you, that is loving species. Diene, loving. So that is having only one bond. So just to do, it starts interacting. So the reaction will give, follow the mechanism 4+2 cycloaddition. So it is following giving the product like this. Then Ithard reaction, chromic CrO2Cl2, that is giving you CH3 to aldehyde. So the conversion of toluene to benzaldehyde. Toluene to benzaldehyde. Ithard reaction is super important. Please note down. Then Perkin. It is also similar to aldol condensation reaction. Here you can see I am taking aldehyde and what is this? R COO. So this is just giving you alkenes or unsaturated carboxylic acid. It's just also following the aldol condensation type. Navier-Stokes reaction, it is a base catalyzed reaction. It's again giving you unsaturated salt, carboxylic acid salt of carboxylic acid. Cope elimination, syn elimination happens. That is very important in case of cope. Syn elimination means elimination from the same side. Reformate case synthesis, Stephan reaction. This is super important for formation of aldehyde. In the preparation of aldehyde, you could see the Stephan reaction, which is, you can, Stephan ends with CN, ends with N. So cyanide to aldehyde. You can remember it like that, and starts with S. So SnCl to HCl. Okay. So the reduction of nitrile to form aldehyde. Then tolerance, which will give you tolerance test positive, aldehydes will give, that is forming a silver mirror, and in case of Felling's reaction, that will give you the red precipitate over there. Fischer esterification, what are the rearrangements happening over there, that will give you alcohol, and carboxylic acid will give you esters. The applications of Grignard reagents, please be careful with that. Depend on the reactant, it will give you the product. So let's solve some problems to understand what is the importance of give the rearrangement and named reactions. So let's see the first problem, which is asking the product formed when cyclopentanone reacts with I2NaOH. Cyclopentanone. Cyclopentanone reacts with I2NaOH. What is this reaction called? So this reaction, what that will give? I2NaOH, what is that? Alpha position, I'm not having any methyl group. If I would have a methyl group that undergo Hofmann reaction, right? Haloform reaction. So here I am not having any free alpha methyl group. So what that will go? It will undergoes the oxidative cleavage over here. So ring opening will happen, and then that will give you the product of CHI3 and HCOONA. Let's move on to the next question. Benzene on monochlorination gives A, which on treatment with sodium amide. Okay, so sodium amide, which is giving yields B, amide. Then B on acid hydrolysis produce C. So identify C, that is the reaction. Benzene is undergoing a monochlorination. So it will monochlorination, no? So only one Cl will get attached to the benzene ring, and then sodium amide. Reacting with sodium amide, what is this reaction? It follows Hofmann amination. So the answer to this question is option B. Aniline will be forming. JEE Main 2019, Friedel-Crafts acylation of anisole with acetyl chloride and AlCl3. The major product is anisole. What is anisole? Ether compound, is it? So I have told you, Friedel-Crafts acylation, that is an electrophilic substitution. So we have to look for a substituents. So what is this? It is a electron donating group. So it directs ortho and para position. Para position is much more easier because to overcome the crowd. So as simple as that, ortho methoxy acetophenone. Sorry, para methoxy acetophenone. Then the major product in propene gives HBr peroxide. In the presence of HBr peroxide, that is giving, and then KOH ethanol, that is giving X. Okay, so what would be the X forming, the major product formed in this reaction? So propene and then peroxide is present over there. Please note it down, students. Peroxide, in the presence of bromide only, it is forming our anti-Markovnikov product. If that is not following if that is not having Br, if that is having HCl peroxide, then that will not give you Karash effect. So just propene, HBr peroxide, Karash effect, it is undergoing. It will get substituted first. So according to Markovnikov, I have told you which will get richer. H plus will go to more number of H plus side. So CH3 will be forming in case of Markovnikov. Here that is forming just opposite, right? So Br will get attached over here and then CH2, CH3. And it is undergoing KOH ethanol. So KOH ethanol. KOH with ethanol, one type of reaction. KOH with water, another type of reaction. So ethanol means elimination will take place. Water means substitution will take place. So ethanol, you can consider ethanol, that's bad for our health. So undergoes elimination. We have to eliminate it. Just remember like this, it undergoes E2 elimination. So it is forming the product propene again. Then which component gives positive iodoform test? So only acetone and 2-pentanone. What is 2-pentanone? Methane, ethane, propane, butane, pentane. Second position I am having carbonyl group CH2, CH2, CH3. Which will give you positive iodoform test? Acetone will give acetone and 2-pentanone. All ketones are aldehydes. So answer would be acetone and 2-pentanone. We know why. It should have a CH3 in alpha position. Then major product of this reaction, that is pH, that is phenyl ring CH2 Br with KCl. So what would be the major product? It will undergo SN2 substitution at primary carbon. So it will be forming a product. Just a substitution you have to do. Okay, identify A. Amine is giving diammonium salt, that is giving A. See this reaction, identify A. Amine is giving you diammonium salt and that is giving you A. So find the A. Here you can see that is Bal-Schiemann reaction. So which will give you fluorobenzene, right? So the reaction is important. Bal-Schiemann means obviously you can say fluorobenzene is the product. Product, when benzaldehyde react with concentrated KOH. Critical product, benzaldehyde react with concentrated KOH. So what is this reaction is? This which is not having any alpha hydrogen, so which means that is Cannizzaro reaction, right? So Cannizzaro reaction means what are the products? I have told you Cannizzaro reaction undergoes disproportionation reaction. So that will give you alcohol also and carboxylic acid also. Is it? Or different carboxylic acid salts. You can see here benzyl alcohol and potassium benzoate. So that will be your answer. Then reagent to convert acid chlorides to aldehydes. So acid chloride to aldehyde, Rosenmund reduction. So Rosenmund reduction means immediately this reagent should strike your mind. Rosenmund reduction. This is Clemenson. So that will not give you, that is conversion of CO to CH2. That will not give you, and sodium ethanol will not give, and this guy sitting over there is a strong reducing agent but not give you for acid chlorides to aldehydes. This question is very important. This reaction itself is very important. So many questions can be asked in case of Rosenmund reduction. So what is BaSO4? BaSO4 is a poisonous catalyst. And what is PD? PD is a catalyst for this reaction. So please be careful with this kind of question. Please be mindful. And product of CH3COCH2 COO, okay, that is giving you in the presence of NaOH and I2. So what is the product? Here you can see I2NaOH. What is that? Haloform reaction. So haloform reaction means what happened? It is a form of oxidation reaction. Okay. So you can see haloform that is forming over here. Do we have any free alpha CH3 group? Yes. So iodoform is formed. Along with that, I'm having an oxidized form, that is CH3COONA. Decreasing order of reactivity towards nucleophilic addition. Based on the steric hindrance, you can easily answer to this. Which is the decreasing order? Just to suggest and give me A, B, C or D in the comment section. And this question asked in 2023, which is pH with CH2Br, that is giving you MgBr, and that is giving us, and again alcohol. MgBr, by seeing MgBr itself, the Grignard reactions must be taken place. The second step uses. So what is used? The Grignard addition to the formaldehyde had happened, right? So the answer is HCHO. Major product of Riemann-Tiemann reaction of phenol. So Riemann-Tiemann reaction means what is the major product? Orthoformylation is preferred. So ortho, that is a major product. Ortho, because it can form a hydrogen bond to which makes it much more stable. Ortho is stable. That is more major. Then acetophenone with zinc amalgam and HCl gives acetophenone. Clemenson reduction, just instead of CO, just put CH2. What is the name of the product? Ethyl benzene, acetaldehyde, ethanol, benzyl alcohol. What is that? That is ethyl benzene. Best sequence for the benzene to benzoic acid. So benzene to benzoic acid. So what had happened over here? What are the reagents given? CH3Cl with AlCl3, Friedel-Crafts, alkylation, and then K1O4OH minus oxidation. So Friedel-Crafts alkylation means you can expect CH3 will be getting substituted on the benzene ring. and CH3 should get converted to benzoic acid, or what else, direct oxidation, CO2 AlCl3, that will not take place, and this only will not give. So you can go with Friedel-Crafts alkylation, which will give you CH3 upon oxidation using KMnO4, and basic condition, this will give you benzoic acid. So the answer to this question is option A. So please practice more and more question. I'll be attaching a practice question paper in the description link. So practice those questions as well, which are anticipated questions for this year JEE Main. So I'll be attaching the checklist for the named reactions. So once you have did revision of entire chapter, entire organic chemistry, please do check those reactions, put the tick mark once you are done. Do the mechanism, do one example, that's you got it. Please practice more because practice makes a man perfect. Thank you.